Hello, my name is Beth Dixon, and I am the Math Lab Coordinator and work in MBSS 222, the Math and Behavioral Social Science Building. It is my job to help students with their math here at Walter State. And to assist with that, I am making these podcasts on certain topics in our math courses. This particular topic is very limited. It's one topic, and but it's one of the topics that students struggle with, and so I just wanted to show you a couple of examples, and it's basically for our DSPM 0850 students, although some students may need it for our 1710 class, as well as maybe our 1630 class and our calculus class maybe even, but it's really based and directed for our 0850 course, where they're asked to find any values of the variable that make the expression undefined. In this case, what we're talking about is rational expressions where we have x in the denominator. And when we have x in the denominator, we have to remember that that variable cannot make our denominator 0. We have two things that we're not allowed to do in the real number system. And in the real number system, the two things that we're not allowed to do is we're not allowed to divide by 0, and we're not allowed to take square roots of a negative number. There are some other things, but those are the two main ones that we look for when we're describing the domain of a function. And as these lectures and podcasts that I'm doing are not meant to replace your teacher's lectures in your class time, I'm not covering the entire topic. I'm really focusing on this very specific idea. So I'm really looking at how in rational expressions our denominators can be 0. So since we can't divide by 0, we cannot let the variable assume any value that would make the denominator 0. So in our first example here, we have 5 over n. So our n is in the denominator. Remember, the denominator is the bottom part of our fraction. So when we're asked to do this, we simply look to the bottom of our fraction, take whatever is there, and say that it can't equal 0. Then we look to see if that equation is solved for that variable, in this case n. N is solved for itself. N is by itself, so n is solved. So for the first one, it's just n can equal 0, and we're done. Let's look at the second one. X squared plus 2x minus 15 over x minus 3. In this one, x minus 3 is in my denominator. It's in the bottom of the fraction. So I take whatever's in the bottom of the fraction, I make it equal to 0, and then I'm going to solve for x. Well, that's a simple linear equation that we can solve by adding 3 to both sides. 0 plus 3 is 3. I have solved for x. X is by itself, so x can equal 3. If I put 3 back into this equation, I would get an error because I would have 3 squared plus 2 times 3 minus 15 over 3 minus 3. 9 plus 6 is 15. 15 minus 15 is 0. I'd have 0 over 0, which is undefined. So I cannot put back 3 into this equation. Every other value is okay except for 3. Now, do I need to do this? No, that was just showing you why it's so. Okay, let's look at this one. Okay, I have x squared plus 3 over x squared minus x minus 12. I take and set it equal to 0. I do not care about the numerator. The numerator does not affect anything. The numerator actually can be 0. It doesn't matter. I have to restrict the denominator. The denominator cannot be equal to 0. Now, the best way to solve this one is with factoring. Now, you may groan I can't hear you, so that's okay. And so you can groan all you like, but I swear to you, factoring is the easiest way to do this one because because it's a 1x squared, we're going to put our x there and our x there. What multiplies to be 12 and subtracts to be -1? Well, what multiplies to be 12 is 1 and 12, 2 and 6, and 3 and 4. Since it's a negative, we're going to subtract. 12 minus 1 is 11, 6 minus 2 is 4, 4 minus 3 is 1. Since I'm a negative, my signs are different, and the larger of these match the middle term. There, I factored it. I can do that quicker than I can use the quadratic formula. I can do that quicker than I can pull out the calculator and cheat and use your quad program if you've got that programmed into your calculator. Then I can go x minus 4 equals to 0 and x plus 3 equals to 0. Add 4 to both sides, x equals 4. Subtract 3 to both sides, x equals -3. Now, in this case, there are two values where x equals 0. And both of those values would have to be restricted. Notice I put a big line through it because those are the two values that would make this denominator equal to 0. So sometimes you can have more than one answer. Okay, let's look at our last example here, x minus 3 over x squared plus 5. And we're going to take x squared plus 5 equal to 0. Well, that doesn't factor. There are no factors of 5 that add to be a 0x. We can only factor differences of two squares. If I use my quadratic formula, I'm going to get no solution because my determinant, b squared minus 4ac, is 0 squared minus 4 times 1 times c, which is 5, and gives me -20, is negative. And you can do the whole kit and caboodle there of your quadratic formula to prove it to yourself, but you still get -20 under the square root. So that means no solution. Now, you can do it that way, but I also want you to just look at x squared plus 5. Think about the x values we can put in. We can put in a positive number. Okay, if I put in a positive number and square it, I'm going to get another positive number. A positive times a positive is a positive. Add it to 5. Am I going to get 0? No. If I put in a negative number, a negative times a negative, that's squaring it, gives me a positive. A positive number plus 5 is not going to get me to 0. X squared is always going to be positive. Any positive number plus 5 can never equal 0. So also just my logic looking at this tells me that this can never equal 0. So there's no place where this will be 0. So this one, find any values. There are no values where this x is undefined because of the way the problem was worded. And again, I pointed, but I didn't bring it back down so you could see because my direction said find any values of the variable that make the expression undefined. Now, if it asked me to find the domain of this function, then that would mean that the domain of this function is all real numbers. Because I didn't leave any values out, I'm containing all the real numbers. I hope this helps you figure out how to determine which values to exclude from your domain as you look at rational expressions. If you need some additional help, be sure to come and see us in room 222 of the Math and Behavioral Social Science building. Getting tongue-tied this afternoon. Have a good afternoon.